By the last problem, let us conclude the quadratic equation. In this video, let us discuss the fifth problem of exercise 4.3. Is it possible to design a rectangular park of perimeter 80 meter and area 400 meters square? If so, find its length and breadth. Here, the possibility of the design of the rectangular park with the given condition. If yes, we have to find its perimeter also. What is known here? Perimeter of the rectangular park can be written as 80 meter. Area of the rectangle can be written as 400 meters square. Perimeter of the rectangle can be found by the formula 2 into length plus breadth is equal to 80. Let us take it as equation 1. Area of the rectangle can be written as length into breadth is equal to 400. Let us take it as equation 2. By solving the equation in 1 and 2, we can write 2 into L plus B is equal to 80, L plus B is equal to 40. So I can write L is equal to 40 minus B. Substituting the value of L as 40 minus B in the equation 2, I can write 40 minus B into B is equal to 400. If I multiply, I will write 40B minus B square is equal to 400. If I shift 400 to the LHS side, I can write 40B minus B square minus 400 is equal to 0. Or to convert it in the form of AX square plus BX plus C is equal to 0, I can write B square minus 40B plus 400 is equal to 0. Next thing, by applying the discriminant formula, I can write B square minus 4AC. That is, the value of A is 1, the value of B is minus 40, the value of C is 400. If you substitute the value of A, B, C, you will get the answer as 0. Therefore, it is possible to design a rectangular park with the given condition. So, we have to take the formula x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. By substituting the value here, I will get the value of breadth as 20, length is equal to 40 minus b, that is 20. So, this condition is possible. Yes, therefore, possible to design a rectangular park with a side is equal to 20 meter. So this is the last video of the quadratic equation. In this video, we all concluded all the problem of exercise 4.1, 4.1, 4.3.